Hello, 8th grade Grizzlies. This is Miss Brown, and this is a review for your force test, which is scheduled for Tuesday, March 8th. All right, so we're going to go through this entire review sheet, and then I'm going to do another video that's going to focus on the second law, which is force equals mass times acceleration. I'm going to do a separate video with some extra practice on how to use that formula. Okay, so I'm going to go through and start this review sheet. All right, so first thing you need to do is put your name here because you are awesome. Okay. And this is actually Newton's laws of motion. This is your test review. All right, so we're going to define each of Newton's first laws, then 4 through 12 is practice, and then a few more definitions, and then some calculations. All right, here we go. Newton's first law is also known as the law of inertia. Okay. All right, so Newton's first law has two parts. An object in motion will remain in motion, or an object at rest will stay at rest unless acted on by an unbalanced force. Okay. Sorry, there's something under here that's making it difficult to write. Okay. So you go ahead and write that down, and I'm going to explain a little bit. So basically, an object in motion will remain in motion, or an object at rest will stay at rest unless it is acted on by an unbalanced force. So a soccer ball sitting on the ground is going to stay at rest unless an unbalanced force acts on it. So that could be someone kicking it, someone picking it up. Okay, so remember that a force is a push or a pull. Okay. Or an object in motion will stay in motion unless acted on by an unbalanced force. So a ball rolling. A ball in motion is going to stay rolling until friction, eventually friction will slow it down, but it wants to stay in motion at the same speed and the same direction. Okay? All right, we're going to do Newton's second law. This is also known as the law of acceleration. So basically, Newton's law is the formula, which is force equals mass times acceleration. Okay, so basically this is the more mass you have, the lower the acceleration. Okay, less mass equals more acceleration. And I don't know why I put a C there with acceleration. That doesn't go there. Sorry about that. I'm writing too fast. Okay, so basically, it's basically saying that the less mass you have, the more acceleration you're going to have, versus something that has more mass has less acceleration. So for example, when we did these stations, okay, we had a tennis ball and we had a golf ball. Now some classes had the ping pong ball and it didn't quite work out, so I'm going to use the tennis ball and the golf ball as the example. The tennis ball had less acceleration because it had more mass. So I think when we weighed the tennis ball, it was like 45 grams, and the golf ball, no, the tennis ball was like 56 grams in terms of mass, and the golf ball was like 45 grams in mass. Okay, so when we let them roll the 2 meters, it took the tennis ball longer to get to 2 meters. Why? Because the tennis ball had more mass than the golf ball. So another example would be a big truck versus a small car. If they both accelerate with the same amount of force, the smaller car is going to accelerate much faster because there's less mass. Or, I've heard another teacher describe it. Let's say you have the same car. So for the sake of, let's just say you have a Ford Explorer. Okay? And you're driving to San Antonio in this Ford Explorer and it's just you. You're going to use less gas because there's less mass in the car. But if you load up all your friends and you have your car packed, let's say with 8 people, you have more mass. So you're going to use more gasoline to get to San Antonio than you would if it was just you. So more mass equals less acceleration. Okay, so that's just another example that might help you kind of understand that. All right, onward. Newton's third law. Newton's third law is called the law of action, reaction. And with this law, you often will see the arrows. So you might see the arrows like this or like this. So this law states for every action, there is an equal and opposite reaction. Okay, so the example that I tend to use all the time with my students is a rocket. When a rocket gets ready to take off, the gases from the rocket push down on the earth. The earth then pushes back on the rocket. So the gases are pushing down. Earth is pushing up on the rocket. Another example is one of the task cards you did when we did the stations was a canoe. You push the water backwards, but you move forward. So you're pushing the water backwards with the paddle, but you're moving forward. Another one is a skateboard. Someone on a skateboard. You push back with one leg to propel yourself forward. Okay, so that is the law of action-reaction. Alright, so what we're going to do now is we're going to go through these examples. Now on your test, there are several questions where you have to decide whether it's the first, second, or third law. You do need to know that the first law is also called the law of inertia. You also need to know that the third law is called the law of action-reaction. Okay? And then there will be several examples on your test that you will have to identify whether it's the first, second, or third law. So that's what we're going to do now. All right, so a climber pulls down on a rope in order to lift his body upward. That is the third law. Okay, force equals mass times acceleration. That is the second law. That's the formula for the second law. Two bumper cars collide into each other and each car jolts backwards. Okay, so the bumper cars hit like this. One bumper car goes backwards and the other one goes one way, one goes the other way. So they hit each other, and they bounce back. That's the third law. For every action, there's an equal and opposite reaction. Number 7, when you give your friend a lift on your bike and you have to pedal harder and faster to keep the same speed as you had when you were on your bike alone. That is the second law. Because you have more mass when you add your friend. Right, so you have more mass when you add your friend, so that is going to make you apply more force to get the same acceleration. Okay. Sorry, there is something under here that's making my pen skip. Okay. For every action, there's an equal and opposite reaction. That is the third law. All right, a smaller cannonball leaves a cannon much faster than a heavier cannonball. All right, so this is a smaller cannonball, not bar, cannonball, leaves faster. So that means it has, it leaves faster. So the smaller cannonball, has more acceleration than a ball with more mass is fired than a ball fired than a heavier cannon fired at the same time. Okay, so this is more mass. The smaller one leaves faster. This is the second law, mass and acceleration. All right, number 10. When you're standing on a subway train, your body suddenly stops. Okay, let me retry this. My goodness, I'm sorry. When you're standing in a subway train and the train suddenly stops, your body continues to move forward. That's the first law, the law of inertia. Even though that train stops, your body is still in motion. So you're going to be thrust forward. Same thing in a car. If you're in a car without a seatbelt and the car suddenly stops, you're still in motion. So you're going to lunge forward. Another example I used in my classes is a lot of times when I'm driving home, I'll have groceries or something in the back seat. When I when I stop the car, I stop because I am seat belted in the car. I'm part of the car, so I stop. But the groceries are in motion, so they all roll forward and sometimes out of the bag and all over the back seat of the car. That's the first law. Okay. All right, number 11. It is much easier to carry your backpack when it is empty than when it is full. This is referring to mass, and it's easier with less mass than it is when it is full, more mass. So this is the second law, mass and acceleration. And the last one, a boy is going down a slide. He reaches the bottom. As he reaches the bottom, friction causes him to slow down. All right? Well, this is the first law. An object in motion is going to stay in motion. That's the boy going down the slide. When he reaches the bottom, friction, that's the unbalanced force, is going to stop him. That's the first law. Number 13, what is inertia? Okay, so inertia just means an object's resistance to a change in motion. So basically, inertia just says an object wants to keep doing what it's doing. If it's at rest, it wants to stay at rest. If it's in motion, it wants to stay in motion. Okay? So an example that we did not do this year that we have done in years past is, and maybe I can demonstrate that. Let me pause here and do a quick setup, and I'll show you what I'm talking about. Okay, I'm hoping this is going to work. So I have this, this is a paperclip cup. I have an index card and I have a penny. All right. So if I come along and I flick the index card, the penny falls down into the cup. Why? Because the penny wants to keep doing what it's doing. An object at rest wants to stay at rest. It resists the change in motion. So it does not go flying off with the card. It just falls straight down because it wants to stay at rest. It doesn't want to change its motion. So that is an example of not only the first law, but an example of inertia. An object's tendency to resist a change in motion. Okay, onward. How are mass and inertia related? More mass equals more inertia. Okay. So the more mass it has, the more it wants to resist a change in motion. The example I've been using with my classes are, I know you all don't drive yet, but that's why you do not, it's not safe to get in front of an 18-wheeler and jam on brakes. Why? Because that 18-wheeler has so much mass, it has more inertia. It resists a change in motion, which means it's going to take it longer to slow down than it would if it was a smaller vehicle. So the more mass you have, the more it wants to resist a change in motion. All right, let's go on to the second page. All right, how does mass affect acceleration? Well, this is referring to the second law. So the more mass you have equals less acceleration. Less mass equals greater acceleration. Okay, and I think I gave an example of that. Yes, I wrote that here under the first law. All right, so these 15, 16, and 17, these all deal with the second law. Okay, so kilogram, that measures mass. I'm just writing out the formula. The second law is force equals mass times acceleration. Okay, so for the second law, mass is always in kilograms. The N stands for Newton, and it measures force. So your force is always in newtons. And anytime you see meters per second square, that is acceleration. right, moving on. Number 19. So 19 through 27 all deal with the second law. So what are the three formulas that describe the relationship between force, mass, and acceleration? All right. So I'm going to draw the triangle and I'm going to write out each formula. So force equals mass times acceleration. So force equals mass times acceleration. Acceleration equals force divided by mass. And I'm going to have you put a box on this one and a star, because this is the one you're going to be most likely to have to solve for on your test and on STAR. Acceleration. And then mass is equal to force divided by acceleration. So these two are the ones you're going to have to know the most. The main formula, force is mass times acceleration, and then acceleration is force divided by mass. Okay? All right, so questions 20 through 27 all deal with you being able to manipulate the formula in order to find out, in order to answer the question. So I am going to pause and grab a calculator, and then I'm going to work through each one of these questions with you. And then, like I said, I'm going to upload a second video that also has more practice with this, because all of us 8th grade teachers really want to make sure you understand how to do the math for the second law. Okay. So number 20, it says a force of 52 newtons acts upon a 4 kilogram block sitting on the ground. Calculate the acceleration. Okay, so they give you the force and they give you the mass. They want to know the acceleration. Okay, so there's one of two ways you can figure out the correct formula. You can come to the triangle, cover up the A, acceleration is force divided by mass, or you can write out the formulas. Okay, so acceleration is the force, 52 newtons, divided by the mass, which is 4 kilograms. Your acceleration is always in meters per second square. Okay, so we're going to do 52 divided by 4. Your answer is 13 meters per second square. All right, number 21. A 5 kilogram block, that's your mass, is pulled across a table with a force of 61 newtons. Calculate the acceleration. Okay. So again, I'm going to come over to my formula. I cover up the A. Acceleration is force divided by mass. So then I plug in my numbers. So my acceleration is my force, 61 newtons, divided by my mass, 5 kilograms. My acceleration, again, is in meters per second square. So I'm going to plug it in, 61 divided by 5, I get 12.2 meters per second square. Now I know, ladies and gentlemen, it's a tedious process of reading the question and circling the information, but trust me, if you do it in this manner, it will help you, and chances are you will get the correct answer. Okay, I know it's a lot like math, but it really does help you. All right, 22. A roller coaster pushes a 20 kilogram person, 20 kilograms is mass, upward with a force of 300 newtons. That's your force. What is the acceleration? Again, I come to my formula. Acceleration is force divided by mass. So my acceleration is going to be equal to force divided by mass. So my force is 300 newtons. divided by my mass, 25 kilograms. Acceleration is always meters per second square. So I do 300 divided by 25. My answer is 12 meters per second square. Okay? All right, number 23, it says an object with a mass of 10 kilograms is accelerated upward at 2 meters per second square. That's your acceleration. What is the force? All right, so it's asking me to find force. So if I cover up my force, force is mass times acceleration. So force is m times a. So my force is my mass, 10 kilograms, times acceleration, 2 meters per second square. Remember, force is always in newtons. So 10 times 2 is 20 newtons. Okay, question 24. What is the mass? So they're asking you to find mass of an object if a force of 17 newtons causes an acceleration of 1.5 meters per second square. Or actually it says meters per second. That's just second square. Okay? So it's asking me for the mass. So if I come and cover up my m, mass is force divided by acceleration. So I write my formula. Mass is force divided by acceleration. So I plug in my information. Mass is equal to my force, 17 newtons, divided by acceleration, 1.5 meters per second square. Mass is always in kilograms. Okay? So, 17 divided by 1.5, that gives me 11.33 kilograms. All right, question number 25. What is the acceleration? So you're asking you to find acceleration of an object, of a 10 kilogram object, so that's your mass, if a force of 3 newtons is applied to it. All right, so I come up to my formula. They're asking me to find acceleration. So I'm going to cover up the A. Force divided by mass is acceleration. So my acceleration is force divided by mass. My acceleration is 3 newtons. That's my force. Divided by my mass, which is 10 kilograms. Acceleration is always in meters per second square. So I'm going to plug it in. 3 divided by 10. So my acceleration is 0.3 meters per second square. All right, onward. And I'm going to rewrite my formula down here at the bottom, just so I don't have to keep scrolling up. All right, what is the mass of an object that requires a force of 25 newtons to accelerate it 5 meters per second per second? All right, so meters per second square is the same thing as meters per second per second. It's asking you to find the mass. They tell you the force is 25 and the acceleration is 5 meters per second square. So I want mass. So I cover up the m. Mass is force divided by acceleration. So my mass is equal to my force, 25 newtons, divided by acceleration, 5 meters per second square. Mass is in kilograms. 25 divided by 5 is 5. All right, last one. How much force is required to accelerate an 1,800 kilogram truck 3 meters per second per second? Again, 3 meters per second square is the same thing as meters per second per second. That's your acceleration. Your mass is 1,800 kilograms, and it's asking you to find the force. Well, that's just the basic formula. Force is mass times acceleration. So your force is equal to your mass, 1,800 kilograms, times your acceleration, 3 meters per second square. Remember, your force is always in newtons. Okay, so we do 1,800 times 3, 5,400. Okay. All right, there's one more thing I want to go over, and that will be the end of this part of the Okay, the last thing I wanted to go over with you, ladies and gentlemen, was what we started with this unit doing, and that was calculating for net force. Okay, so I know you've seen this worksheet before. I just wanted to go over it again very briefly because you are going to have to calculate for net force, and then I want to show you another example where you're going to have to calculate for net force in order to use the force to get either the acceleration, the mass. Okay, all right. So when you're calculating for net force, these are the easy ones. So there's no opposing force on this side. So the net force is 225 newtons. It's going to move in the direction of the greater force, and those forces are unbalanced. Same thing here. It's going to move, the net force is 75 because there's nothing opposing it. It's going to move in the direction of the greater force to the left, and it's unbalanced. Now these are the ones that get tricky when you have several numbers on one side. So for example here, you have 100 newtons on this side, you have 50 and 50. So this is 100 newtons. So the net force is 0 because it's 100 minus 100. So the net force is 0. The forces are balanced and it is not going to move. Or if it's at a constant speed, it's going to stay at a constant speed. Either way, there's no change in the motion. Okay, this one over here. Okay, so what you have to do is add all these forces on this side, add the forces on this side. Okay, so 400 plus 900. Oops, let me put that in wrong. 400 plus 900. So this side is 1,300 newtons. Okay, this side is 792 plus 632 plus 100. So this side is 1,524 newtons. All right, so which side has the greater force? The left side. So the box is going to move to the right, okay, because it's pushing this way. So now for the net force, you're going to subtract 1,300. You get 224 newtons is your net force, and it is unbalanced. Okay. Same thing here. You have 1,563 newtons on this side. So let's add up this side. So you have 550 newtons plus 750 newtons plus 250 newtons. So this is 1,550. So it's going to move in the direction of the greater force. Well, the greater force is here because 1,563 is greater than this one. So it's going to move to the left. So now we need to get the net force. 1,563 minus 1,550, 13 newtons, and it is unbalanced. And the last one. So you have 987,256, 993,267. Which side has the greater force? Right here. So it's going to move to the left. So now you have to subtract to get the net force. So 993,267 minus 987,256, 6,011 newtons, and it is unbalanced. Okay? So I know we did this, but I just wanted to refresh your memory on it. Okay, last thing I'm going to go over is this here. Okay, so it says, the diagram below shows two different forces acting on a cyclist riding a bicycle. If the total mass of the cyclist is 50 kilograms, based on the information, what is the acceleration of the cyclist? Okay, it's asking for acceleration. So we're talking about the second law. So we're going to use the triangle. Force is equal to mass times acceleration. It's asking for acceleration, so you're going to use the formula. Acceleration is force divided by mass. Okay? Now in this question they give you the mass is 50. So your mass is 50 kilograms. Well, what's your force? Well, they said that the driving force is 25 and the frictional force is 20. So how do you get the force? Well, this is where you're going to combine what we just looked at in terms of you have to find the net force first. Then you can use that force to calculate the acceleration. Okay? So your force, you have 25 newtons to the right, and you have a friction of 20 newtons to the left. Okay? So the bicyclist is going to move to the right because that's the greater force. But we need to subtract to find the net force. So 25 newtons minus 20 newtons. So your force is 5 newtons. Now you're going to use this force in the equation to find the acceleration. So acceleration is force, 5 newtons, divided by mass, 50 kilograms. Remember, acceleration is always in meters per second squared. So we're going to do 5 divided by 50. 0.10 is her acceleration. Okay, so we can X out A and B. Now, is she going to go backwards or forwards? Well, the right has the greater force. We already said that. So your answer here would be C. All right, ladies and gentlemen, this concludes your review for your force test. I am going to upload another video where I'm going to do maybe 5 or 6 more problems using the force is mass times acceleration formula, just for those of you that might want a little more practice. I'm going to do another video that focuses just on the second law. But for this review sheet, I'm done. So on behalf of Ms. Roberts, Mr. Winter, Ms. Smith, and Ms. Ford, this is Ms. Brown. We believe in you, Grizzlies. Please review your notes. Think about the stations that we did last Thursday and Friday, and go through this, listen to this review video, and you should do well on your test.